Okay, so he says there's two things that contradict the rising Earth claim. One, parachutes, and two, lack of displacement in accelerating bottle. Parachutes show the true vector of the object that it's connected to. A decelerating bottle without displacement has never been seen. See, this is the thing though. He says an accelerating bottle without displacement has never been seen. And to be honest, he's right. Like, you can't show acceleration that is actually known acceleration, like actual physically made to accelerate. You can't show an accelerating bottle without displacement. That's the whole point of the special pleading with dropping a bottle. Although you can measure an optical acceleration towards the ground, you know, in every other case of acceleration where it is actually properly known acceleration, where you are actually physically accelerating something, there is always displacement. And yet, when we drop something, there isn't displacement. That's his whole point. It's possible to determine the true vector of a drop bottle. Get a bottle, attach a mini parachute to the top and another one to the bottom. With the bottle held in your hand, the one on the top will be filled up, resting limp on the top of the bottle, while the one on the bottom would be hanging loose, but also filled up. Now then, when you release the bottle, it will visually accelerate and close the distance towards the parachute on the bottom pushing against it, while the one on top will unfurl, showing you the direction of travel through the air resistance. Now then, if you let go and it was supposed to be decelerating upwards, the one on the top would remain filled up where it was, while the bottom one would unfurl, showing the air resistance and vector. Nope, physics don't lie. Okay, so if we say we have a bottle, and we have a parachute on the top, and a parachute on the bottom, so these are the represented parachutes. Don't really need to worry about the floor, because the floor is irrelevant. Even though it's moving up, it's about what's happening with the bottle and the parachutes. So obviously, if the earth was moving up at a constant speed, the air is moving up at a constant speed with it, so everything's basically in place. So there's no air resistance basically to affect the parachute, so they just lie flat. They lie floppy. Okay, so as you take it up off the ground, if you was to drop the bottle, so with Dell's, obviously this was moving up at constant speed with the earth, and obviously if you drop the bottle, then he's saying it's decelerating, so therefore it comes down to the ground, because it's no longer keeping that speed. So basically it's losing its momentum. It's no longer keeping that speed of the earth, so the earth catches up with it because it's no longer keeping that speed. If it was keeping that speed, then it'd stay the same distance away from the earth, but it's not keeping that speed, it's losing that speed, so therefore it comes down to the ground. But by saying it's losing that speed, by saying it's decelerating, you are saying that actually the acceleration is downwards, even though you're saying it's deceleration. Acceleration is a change in velocity over time, so if this is not keeping that speed and it's changing its velocity over time, and its changing velocity over time is not in the upwards direction, it's in the downwards direction, then actually you are saying it's accelerating down anyway, so you're still claiming downwards acceleration, which I didn't really think about, but yeah, you are. So where was I? Yeah, anyway, so as it's losing its speed, obviously the air would, the ground would be pushing up on the air, and as it's coming down, this one's going to turn into like an arc up kind of thing, and then you're trying to say that the bottle would hit the parachute, the bottom of the bottle would hit this one. The thing is, you've got the parachute on top, and you've got the air resistance here as well hitting this, which is going to slow down this one even more. You know, slow down its deceleration rate. So its rate of deceleration is going to be even slower. So if its deceleration rate was going like this originally, you're now slowing that down, so now it's going slower because of the air resistance. So no, it doesn't debunk it, I'm afraid. I think you misunderstood because you said deceleration in the upwards direction. He's not claiming deceleration in the upwards direction. Just that it was moving up with the earth at a constant speed, and then it loses that speed basically that it had from the earth, and therefore comes down to the ground. So unfortunately it doesn't debunk Dell, but still he's claiming downward acceleration still anyway, without realising it just by saying deceleration. He's just saying that it's losing its momentum. I suppose it depends on what way he's looking at it, but to the physics community, acceleration is changing velocity over time. If this is changing its speed, changing its velocity from the Earth speed, so if it was keeping the Earth speed, it'd be the same distance. If it's changing its velocity over time, it's no longer keeping that distance and it's changing its velocity down. So obviously, well, it's going up with the Earth and it's got the Earth speed, but then when you let it go, then it's losing that. The acceleration would be in the down direction, so he's still climbing downwards acceleration anyway, without realising it. So yeah, unfortunately it doesn't debunk Dal, but Dal is still climbing downwards acceleration without realising it. But yeah, actually I would say it still does debunk Dal, because, you know, I did bring this up to him before about the deceleration and that. And, you know, if there's deceleration, then there should be displacement, because deceleration is acceleration, just in the opposite vector, basically. But, and obviously when you decelerate in a car, you still get displacement, don't you? So, but yeah, I brought that up to Dale before, and he was just like, well, it depends on the rate, basically. It's too slow to see a displacement, so the deceleration is too slow, or something like that. But that's the thing, the deceleration would be 9.8 meters per second, wouldn't it? So, no, it's not too slow. You would see it. So the problem that he's arguing about is the same problem that he actually has, even with a constant moving upwards Earth. That's why I say the acceleration is up. But I also, you know, think of it in an Einsteinian way, where the proper acceleration is up of the Earth. And then you got the bending and warping of space-time, so yeah. Because obviously the Earth's a globe. But yeah, I'd say the deceleration point debunks Dale, and it still shows that he's claiming a downwards acceleration. He just doesn't realise he is.